Okay, let's talk about binary search tree iterator. So you have to implement the BST iterator class that represent iterator over in order traversal for binary search tree. So this is the method, and you can just read it by yourself. And this is what it is. So you can construct the tree 7, 5, 7, 3, 15, no, 9, 20, right? This is the tree. And when you go next, call the function next, then you call the function 3. Then the next one is 7, right? 7, and then does it have the next? Yeah, it does, right? So you will just keep true and 9, and then just so on. So what I do is I create a list of integer for every single no value, and I have an index to keep track of the current index and the size of the tree. So here it is. I'm gonna say list of integer equal to list, and I do have an index. So list equal to new array list, index start from 0, and this is in order traversal, right? So I have a type of function I'm gonna call in order root and public. So this will be a standard in order traversal. We know I'm gonna call root. So if root equal to no, just return, and then in order root are left, so keep going left, and then until it leave, and then you just add the value into the list, and then go on your right. And this is the standard in order traversal, right? So what do you do for the next? You need to return a value, right? So return list.get index plus. So when you say next, right, you need to print the current, the one you need to print, and then you need to move on the next one. So this is what I did, plus. So I will return the value for the current index, then I increment my index after this line compile. And then how do I do for the hash next? So I just a boolean, right? So I just say list index is less than list dot size. So if the current index is less than the tree dot size, which is tree dot size, right? This dot size is equal to tree dot size. Then it's true. So this will be the solution, and they just run it. It's not hard, but just think about how you actually need to write. So let's talk about time and space complexity. So for each method is different. So this will be all of one for time and space because you're using get, and you don't need space, but the time is all of one. So this is constant for time and space, and this is constant for time and space. This is the check-in boolean, right? And in older method, the space complexity is actually all of n, right? You need to store every single one, and the time is all of n, right? Because you need to traverse on your left and on your right. So in order method is all of n. For time and space complexity, has next, and next is constant for time and space complexity. And this is a solution. And if you feel this video is helpful, then leave a like, subscribe if you want it, and leave a comment if you have any question. Alright, I will see you next time. Bye.